All right, so I'm going to go ahead and go through this practice quiz step by step to kind of help you out if you are struggling. All right, so if you recall, there are kind of three forms of our rational functions that we're going to need here. We have our original, and then we're going to have our factored form. So to get to our factored form, we obviously have to factor. So in this case here, we do have a GCF in the denominator that I'm going to take out first. So I get x squared minus 2x minus 8. So now we've just got some easy factoring here. So we end up with x plus 3, x minus 4 on the top, and then negative 3, x plus 2, and x minus 4 on the bottom. All right, so this is our factored form. And then we have our simplified form. So in this case, our simplified form, we have to cancel out those x minus 4s. So on top, we end up with x plus 3, a negative 3, and x plus 2 in the denominator. All right, so now that we've got all three forms, we can go ahead and find all the things that we need. So for our horizontal asymptote, we use our original. Our points of discontinuity, we're going to use our factored. Our y-intercept, we are going to use our original. The holes, we need factored and simplified. Vertical, we need simplified. And x-intercepts, we need simplified. All right. So for our horizontal asymptote, to determine that, we have to look at our original here and look at the degree of the top and the bottom. The degree on top is 2. The degree on the bottom is 2, so they're equal. When that is the case, you look at the ratio of the leading coefficients. So on top, my leading coefficient's a 1. On bottom, my leading coefficient is a negative 3. So we simplify if we can, but this we really can't. We just end up with negative 1/3. So my horizontal asymptote is going to be y equals negative 1/3. Then we've got our points of discontinuity. To find our points of discontinuity, you're going to set the denominator of the factored form equal to 0. So I've got negative 3, x plus 2, and x minus 4 equal to 0. Now, negative 3 doesn't have an x, so I can't set that equal to 0. It doesn't help me out at all. But I can do x plus 2 equals 0. I get that x equals negative 2. X minus 4 equals 0. I get that x equals 4. So my points of discontinuity are going to occur at x equals negative 2 and 4. To find my y-intercept, I go to my original function, and I have to plug in a 0 for, what I wanted to do? Let me go back and do this. I wanted to do everything for like each thing in a certain color, and I didn't do that. Let's see, we'll do this in blue. So me finding this in blue. All right, and then let's see, we'll do the y-intercept, I guess, in red. So to find the y-intercept, we have to plug in a 0 for x into the original. You could, in theory, plug this into the factored form, but I just think it's easier to plug it into the original. You may have noticed that it ends up just being like the constants on the end divided by each other, but if you didn't notice that, no big deal either. So we just do 0 squared minus 0 minus 12 all over negative 3 times 0 squared plus 6 times 0 plus 24. I end up with a negative 12 over 24, which is going to simplify to negative 1/2. So my y-intercept is going to be 0, negative 1/2. Make sure that you give this as a point, okay? Pay very close attention to how I give all of these answers. For like the horizontal asymptote, the vertical asymptote, those need to be written as equations, as in like x equals y equals. The holes need to be written as points. The x-intercepts need to be written as points, and so does the y-intercept. All right, so let's see. Next, we will do our holes. So to find your hole, you have to look at your factored and your simplified. In my factored form, what canceled is the x minus 4. So what I have to do is I have to take the thing that canceled and set it equal to 0. So I get that we're going to have a hole at x equals 4. So I need to go and plug, or I should say the x value of my hole is going to be 4. To find the y value, now I use the simplified version and I plug in a 4 for x. So I get 4 plus 3 all over negative 3 times x plus 2. So that's going to be 4 plus 2. So on top, I get a 7. In the denominator, I get a negative 3 times 6. I end up with 7 over negative 18. And that is my value there. All right, you can't simplify that at all. All right, and then for vertical asymptotes, we use the simplified version, and we set the denominator equal to 0. So I'll use green for that. So I've got negative 3x plus 2 equal to 0. Obviously, negative 3 equal to 0 doesn't give me anything. X plus 2 equal to 0, I get that x is equal to negative 2. So that is my vertical asymptote. And then for my x-intercept here, let's see, I can do him in, I don't know, what's a fun color I have not yet used? I guess we'll just do brown. I haven't used that one yet. All right, so my x-intercepts, to find my x-intercepts, I set the numerator of my simplified version equal to 0. So I do x plus 3 equals 0. I get that x equals negative 3. So my x-intercept is going to be at negative 3, 0. All right, so now that I've found everything, I need to go and graph the things that I can onto my graph here, okay? So let's see, we had a horizontal asymptote, so I'm going to graph him in black. Remember, your asymptote should be dashed, so I'm definitely going to make sure that this guy is dashed here. And he gets graphed at y equals negative 1/3. So I go here to negative 1/3, and he gets graphed just like that. All right, and then my points of discontinuity, I did that in blue. Oh, actually, I'm sorry, we don't graph points of discontinuity. Your points of discontinuity end up either being a whole or a vertical asymptote, so we account for that when we graph those. Our y-intercept here occurs at 0, negative 1/2. So I go here to 0, I go to negative 1/2, and I plot my y-intercept. And then I have a hole. I did that in purple. And my hole occurs at 4, negative 7/18. Now, obviously, negative 7/18 is kind of a gross decimal. Maybe you can look at that and be like, well, it's kind of close to like negative 0.5. But I feel like it does help to get a decimal equivalent. So I guess actually 0.5 wasn't really even a great, I guess it would be closer to 1/3. So even my guesstimate was kind of bad. I'm not going to lie. So if we want a nice decimal equivalent to graph, that is about 0.38 or 0.4. Okay. So I go to 4, negative 0.4. That ends up being around right here. All right, cool. And then let's see, we've got my vertical asymptote. So again, remember for your asymptote, make sure you use the dash line. And my vertical asymptote occurs at x equals negative 2. So we get that. And then my x-intercept, which I use brown for, I got negative 3, 0. So I go to negative 3, 0. All right, so this is what our graph should look like. Obviously, right, we saw on Delta Math that like the rest of the function can get graphed in there. I'm not even making you guys do that. I just want to make sure that you can, plot your intercepts, your holes, and your what do you call them? Asymptotes, okay? All right, let's go ahead and try this next one here. So let's see. We can go ahead and find all of our versions here. Obviously, this is our original. Oh, it's still writing in dashed form. My bad. R-I-G-I-N-L. All right, so then we have our factored form. Well, there's not much we can factor here. You could, I guess here, obviously you could factor a negative out. That's probably a nice thing to do. So factored form would be x over negative x minus 2. Remember, it definitely helps you to factor out a negative if the thing with the highest power has a negative leading coefficient. In this case, nothing crazy happens. It doesn't really make a difference, but in some cases it really is going to make a difference, so I do recommend doing that. All right, and then we cancel stuff out on top and bottom, but guess what? There's nothing that cancels, so that means that our factored form is our simplified form. All right, so let's see. For our horizontal asymptote, we know that we have to use our original. So I go and look at my original graph. My degree on top is 1, and my degree on the bottom is 1. So I look at my leading coefficients here. Well, my leading coefficient on the top is 1. My leading coefficient in the denominator is -1. So my horizontal asymptote is going to be y equals -1, because it's just 1 divided by -1. All right, so then for my points of discontinuity, I use my factored form, and I just set my denominator equal to 0. All right, so I've got negative x minus 2 is equal to 0. This negative is like a -1. I can't make a -1 equal to 0, so it doesn't help me. X minus 2 equals 0. I get that x is equal to 2. So my point of discontinuity here is going to be at x equals 2. My y-intercept, to get that, I have to plug 0 into my original version here. So I get 0 all over -0 plus 2. I get 0 divided by 2, which is 0. Pay attention to if you have a 0 on top or on bottom. A 0 on top means you got a 0. If you get a 0 in the denominator, that means it's undefined, which means that you do not have a y-intercept. So here our y-intercept is going to be at 0, 0, because we do get an output of 0 there. All right. Now in this case, right, we know to find the holes, we need to look at the difference between the factored form and the simplified form. Well, it's literally the same thing, right? Nothing canceled. When nothing cancels, you have no holes. You would just put none. And then vertical asymptotes. To find your vertical asymptotes, you take your denominator of your simplified version and set it equal to 0. So I get negative x minus 2 equals 0. Obviously, -1 equals 0 doesn't help me. X minus 2 equals 0. I get that there is a vertical asymptote at x equals 2. And then I have my x-intercepts. To find my x-intercepts, I take the numerator of my simplified version and set it equal to 0. So I do x equals 0. That's an answer. So I have an x-intercept at 0, 0. All right, so now we can go ahead and graph all of these things. So let's see. We have our horizontal asymptote at y equals -1. Remember to make this dashed. So I go to y equals -1. Oops, that wasn't as thick as I wanted it to be. Let's see. There we go. We've got our horizontal asymptote there at y equals -1. Like I said, we don't necessarily plot our points of discontinuity because that will be done through plotting the hole in the vertical asymptote. Let's see. Next, we've got our y-intercept. So my y-intercept is at 0, 0. Plot that right there. There's no holes to plot. My vertical asymptote occurs at x equals 2. So I go and plot that. And then my x-intercept is at 0, 0, which I've actually already plotted. In this case, my x-intercept and my y-intercept are the same exact point because it's at 0, 0. All right, so that's all you got to do for that one. All right, next one. So again, we have our simplified version. No, we don't. I'm sorry. You can tell it's getting late and I am getting tired. Okay, we have our original, ORIGINAL. So now we need to get to our factored form. I will say there's going to be 2 steps here to get to our factored form because we have a GCF on top and bottom. So my GCF on top is x, so I take out an x. I get x squared plus x minus 12. My GCF in the denominator is a -4. I take out a -4. I get x squared minus x minus 2. So then I can go ahead and factor this further. So I have x times x minus 3x plus 4 on top. And then I've got a negative 4, an x plus 1, and an x minus 2 in the denominator. All right. So, does that seem right? Negative 2 plus 1. Are there seriously no holes in this one? All right. So now what we can go ahead and do is see if we have any anything that we can cancel on the top and the bottom here, right? And if we look, there isn't anything to cancel, right? So again, our factored form is the same as our simplified. And again, that means that we're not going to have any holes, right? All right, so let's see. We got our horizontal asymptote here. Our horizontal asymptote, we have to look at the degree of the numerator and the degree of the denominator. Now, in this case, the degree of the numerator is bigger than the degree of the denominator, which means we do not have a horizontal asymptote, so we would put none. We have what we would call a slant asymptote, which don't worry about. You just need to know that there's no horizontal asymptote. All right, and then we have our points of discontinuity. So we get our points of discontinuity by taking the denominator of our factored form and setting it equal to 0. So I've got negative 4, x plus 1, x minus 2, and I set those equal to 0. Obviously, I cannot make just a negative 4 equal to 0. X plus 1 equals 0, I get x equals negative 1. X minus 2 equals 0, I get that x is equal to 2. Those are my points of discontinuity. So we have a point of discontinuity at negative 1 and 2. To get my y-intercept, I have to plug 0 into my original version there. So I get 0 cubed plus 0 squared minus 12 times 0 all over negative 4 times 0 squared plus 4 times 0 plus 8. I end up with 0 divided by 8, which gives me 0. So I have an x-intercept at 0, 0. Remember, it's totally fine if the 0 is in the numerator. All right. Now, to find our holes, we need to see what canceled. But guess what? Nothing canceled, right? So we don't have any holes. We would put none. To find our vertical asymptote, you set the denominator of your simplified version equal to 0. Now, in this case, our simplified is our factored form. So we just set 4, negative 4, x plus 1, x minus 2 equal to 0. Like we said, negative 4 equals 0 doesn't give me anything. X plus 1 equals 0. I get x equals negative 1. X minus 2 equals 0. I get that x equals 2. So I have vertical asymptotes at x equals negative 1 and x equals 2. Now to find my x-intercepts, I take the numerator of my simplified version, which in this case is just my factored version, and I set it equal to 0. So I've got x minus 3, x plus 1, no, x plus 4, sorry, equals 0. So I get that x equals 0 is a x-intercept. X minus 3 equals 0, I get that x equals 3. X plus 4 equals 0, I get that x equals negative 4. So we go ahead and, let's see, we get x-intercepts at 0, 0, 3, 0, and negative 4, 0. So now I got to go and plot all of my stuff. So there's no horizontal asymptote to plot. We don't plot the points of discontinuity directly. My y-intercept in this case is going to be 0, 0. I don't have any holes to plot. I do have a couple of vertical asymptotes here to plot. So we're going to plot those at x equals negative 1 and at x equals 2. So that's going to look like that. And then we've got our x-intercepts, which we've already plotted our 0, 0. We do have a 3, 0. And we have a negative 4, 0. All right, so this is all of the stuff we should have plotted there. Alrighty, last one here. So we, of course, have our original. We need to work on getting our factored. So on top, I can take, let's see. I can take a 3 out, and I get x minus 4. In the denominator, I end up with x plus 1, x minus 4. So for my simplified, my x minus 4 is canceled, so I'm left with 3 over x plus 1. All right, so let's go ahead. We'll look at my horizontal asymptote. For this, I have to look at my original, and I look at my degrees. My degree on top is 1. My degree in the denominator is 2, so it's bigger on bottom, which means that my horizontal asymptote is going to be y equals 0. Again, make sure you put it as y equals. If you just put 0, you're going to get it marked wrong. All right, and then for my points of discontinuity, to find that, what color was I doing that in? Did I change up? Yeah, blue. To find my points of discontinuity, I take the denominator of my factored form and set it equal to 0. So I've got points of discontinuity at x equals -1 and 4. All right, next I've got my y-intercept. To find my y-intercept, I plug in 0 for x. So I do 3 times 0 minus 12. 0 squared minus 3 times 0 minus 4. So we end up with a -12 on top and a -4 in the denominator, which simplifies to a 3. So my y-intercept is going to be 0, 3. Next, I got to find my hole. So there is a hole here because something canceled, right? So to find the x value of my hole, I'm going to see what canceled and set it equal to 0. Well, an x minus 4 canceled, so that means that I have a hole at x equals 4. To find the y value of my hole, I need to plug in a 4 to my simplified version. So I've got 3 all over 4 plus 1, which gives me 3/5. So my hole is going to be at 4, 3/5. To find my vertical asymptote, I look at my simplified version and set the denominator equal to 0. So I'm going to do x plus 1 equals 0. What am I doing? I subtract 1. I get that x equals -1. My vertical asymptote is at x equals -1. To find my x-intercepts, I take my numerator and set that equal to 0. Well, in this case, my numerator is literally just a 3. I cannot make a 3 equal to 0, right? I cannot make a 1 equal to 0. Just any number, there's no x on it. You can't really solve that. So I do not have an x-intercept. All right, so now we can go ahead and plot what we can here. So my horizontal asymptote, I've got here at y equals 0. So I go and I plot my horizontal asymptote at y equals 0. My x-intercept is going to be at 0, 3. I have a hole at 4, 3/5. Now, obviously, 3/5 is kind of gross to plot. So 3 divided by 5, that's going to be 0.6. So we know that this is about equal to 4, 0.6. Actually, not even about, that is exactly equal to because it's not repeating. So we go to, where was I at? 4, 0.6. 1, 2, 3, 4. 0.6 would be right about here. All right, and then next up we have a vertical asymptote. So I go to x equals -1. Oop, that needs to be dashed. I've got that. And then I don't have any x-intercepts to plot, so this would be, oh wait, did I? 4, oh no, okay. Let's see. All right. So that ends up being that. So we've plotted everything we can. So we are done.